Hi, today we are going to talk about solar energy estimation. Over the past 4 years or so, I've worked with majorly three different solar energy estimation softwares. We'll just go over that. So today's agenda would be just introduction to this solar energy software. What is the basic basic how does it work actually, and then we'll go over these three softwares which I've actually used in different projects both in India as well as in US. So PVSYST, Helioscope and Aurora Solar. We'll briefly go over the features and pricing basically, and then we'll just summarize it and the pros and cons, if there are any. All the three of them are good in their own areas, and yeah, let's without further ado, let's go ahead. The basics. Okay, so in solar, it's most like the rule of thumb rules the roost. Even in US, like you have NEC standard or NFPA, and right now I think it's NFPA 2020 or 2017 is still in place. For instance, like for current for the sizing of the wires for solar panels, it is recommended that whatever may be the maximum current the solar panels can give, the short circuit current, it has to be sized 1.25 times more than that. There are different types of solar panels also. Yeah, so typically solar panels are from amorphous, then you have polycrystalline, and then you have monocrystalline in the order of efficiency. So monocrystalline, even though it's more efficient, as the efficiency increases, the cost too increases. Coming to the inverters, we have different kinds. You have the micro, string, and the central. So the micro is like each solar panel has one inverter, so it converts DC to directly to AC. String is another it's a much bigger than a micro. Strings, basically strings are like in series. You have series of panels connected, and these string inverters require certain voltage to start up, let's say 400 volts. And let's say your typical solar panel nowadays can give you a VOC of 40 volts, so you need at least 10 to 11 panels in series to power up this inverter. And it's typically more than 5 kilowatt is your string inverters. And then your central inverters are those in megawatts. Basically they have series and parallel connections basically. And so all of that aside, so these are the basic basic things. So for all these softwares, the main input would be what is the location of your solar plant. So based on your latitude and longitude and your altitude, the solar irradiance varies, and that way your energy generation would vary. So that is one input. Second input is what type of solar panel you're going to use, whether it's polycrystalline, monocrystalline. Depends on the cost sensitivity of the project as well. Typically, for rooftop commercials, 400 kilowatt is an ideal size. Monocrystallines are also coming. The cost is almost coming closer to the polycrystalline. Earlier, few years back, polycrystalline was way cheaper than monocrystalline. The technology had not yet matured enough. So that's another thing. And then the inverters, what type of inverters you're going to use. Micros are typically a little bit expensive than string. String is a little bit more expensive than central, but there are different advantages to micros as well. Micros to string to central. Well, the first thing is warranty. Micros are typically warranty period is almost equivalent to your solar panel warranty. It's almost 25 years. String, because they withstand much more higher voltages. They are usually warranties go up to 5-10 years, and central is I think 5 years. So based on these inputs, you are asked to estimate energy. So the typical type of solar installations are like rooftop is like commercials, or you also have rooftop residentials, which are very small, like typically 5 kilowatt, 7 kilowatt. That's a residential, whereas commercial goes up to like 400 kilowatt to 1 megawatt even. Well, beyond 5 megawatt is usually ground mount. So you have different softwares. So here you can see you have PVSYST, Helioscope, and Aurora. So I have used all the three, and let's go ahead with the overview. So these are the different logos of this respective softwares. Let's go ahead to PVSYST. So it has a preliminary design tool for quick estimation. So one thing about PVSYST is that it's much more trusted in India. Talking from the Indian point of view, the report generated by PVSYST is trusted by the banks basically to give you a loan for your solar project. So that is why most of your projects in India, they require PVSYST reports, primarily because of economic constraints. And also one more advantage of PVSYST is like for commercial ground mounts, which typically go beyond 5 megawatt, the other softwares are not able to scale that quickly. So I mean, they are able to scale, but the thing is, the simulation time taken by PVSYST for systems greater than 5 megawatt is way less than the other softwares that I've mentioned. Primarily because PVSYST is like generalized. It kind of puts a single template across the area, and the modeling capability is also not that great in PVSYST, like the 3D abstractions features which we'd see in other softwares. So you can let's go to the features. If you see, so PVSYST, so you have system design. It's a very very plain vanilla interface, and you just choose the desired power or the available area, and you choose a PV module. Usually PV modules are specified in .pan or the pan files, which you have the voltage and the VI curves, VMPP, IMPP, the maximum power point, what is the current, what is the voltage, and then PVSYST will automatically propose the array and system configuration based on your module and the inverter specified, and the system size basically. So most of these softwares, they tend to abstract out much of the calculations and give you very quickly the report. But on the downside, if you don't know what you're doing, you would tend to generate wrong reports. So yeah, you can see, like, you have system sizing, shading scene, simulation results, meteonome, that's like the weather data. You have the database, so over the 10 years, what is the weather, the global horizontal incidence, and the temperature, the wind data. All of this is available in the meteonome. So this and I've been seeing quite consistent updates so right now I think it's at 7 point, so on today's date, 20th December, it's a 7.1, and so I've used 6.4 and all. So if you go to the shop, and you can see the price, this is in Swiss francs, $600 per year, which equates to around 50,000 rupees, Indian rupees. So it's a yearly subscription. Earlier, I think it was a perpetual license, that is, you pay once. It was almost the same price, you pay once and you use it. But now this every year you have different, the solar technology is actually increasing and improving in efficiency and in technology year by year. So it's essential to have a yearly license basically. Okay, so that is about PVSYST in short. I'm sure I have not covered quite not done justice to this. So it's one of the oldest softwares in solar. So it was one of the first solar simulation software. And then came I think Helioscope and Aurora. Both of them are beautiful softwares in terms of the interface, GUI. And you can see it's 5 minutes commercial solar design. So it's always the USP of all of these softwares is that you can do it very easily and swiftly. Even the ones with very little solar knowledge can come up to speed. The features, you can see 3D design. So this is very useful when it comes to residential or commercial rooftops, because you do have considerable obstructions. Like this one is a tree, and these are the HVAC units typically, and you can actually specify if there are shades, you can specify some keep out areas, which in PVSYST is very difficult to do. I don't know right now currently, but it's really useful to do. Alright, so you do have 3D designs, rapid proposals, bankable simulations, and unlimited designs, live supports, single line diagrams. So these are really good, and the help. If you go to the help section of Helioscope, you have a lot of quick tips which greatly enhances your solar design knowledge. And the 3D design is really a good thing. Like, you can export this particular design in the CAD format, and it's very useful for the draftsmen in the companies to actually see detailed 3D drawings. Basically, you can actually do in essence you would actually like to do a permit package as well. So this is basically very much into US standards. So this is it about PVSYST and Helioscope in short. Catch me in another video wherein I'll go over a bit more detail on these web-based tools like Helioscope and Aurora. Catch you then. Thanks for listening.